Hello everyone and welcome back to this channel. Today we will look at the linked list data structure. This is the 11th video in this series, so I'm going to put a link to the playlist in this video description. So the outline for this video is this. We're going to look at what a linked list is, the definition. Then we're going to look at the terminologies used when it comes to the linked list. Then we're going to look at where the linked list data structure is used. Then we look at the types of linked list. We're going to compare and contrast the singly and the doubly linked list, which are two types of linked list. Then we're going to look at the operations performed on a linked list. Right, then we're going to do some complexity analysis, and finally we're going to look at the code implementation of a singly and a doubly linked list. So what is a linked list data structure? A linked list is a sequential list of nodes where each node is an object that contains two fields, which are a data and a link. So if you have started writing programs, you'll be familiar with the term object. Okay, so an object have properties. So a node is an object with two fields or two properties, which are a data and a link. So the data is the value stored at a particular node, whereas a link is a pointer that holds the address of the next node. Okay, so think of a linked list as a chain of objects, right, where each object has two fields, which are a data and a link. Okay, of course I'm going to show you the diagram of a linked list. Okay, but this is the definition. So before we look at the linked list data structure, let us have a quick review of the array data structure. Of course, we've discussed this in the past. Okay, so this is the array data structure. We have the data that we're going to store. These are the data in the array. This is an array of integer, right? Okay, so what to note here is that the elements are independent of each other. So we have 3 here. 3 does not know that we have 4 here, okay, and 4 doesn't know that we have 2 here. So there is no dependency between each cell or each location in the array, okay. And also elements are stored in contiguous, or in other words, consecutive memory locations. So if you check out the location where 3 is stored at 104. Okay, 4 is stored at 108, 2 is stored at 112. Now, if you check out the differences between the memory addresses, you will discover that it is constant. So 104 to 108 is 4, 108 to 12 is 4, 112 to 116 is 4. Okay, so you can see that the differences between the address is constant. So I'm actually assuming each integer is taking 4 bytes. So just take that the 4 difference as 4 bytes. Okay. So now that we understand the array, we've had a quick review of the array. Let's check out the linked list, which is our major focus. So what is a linked list? Now, when you check out this diagram, okay, the first thing to note is that the elements are dependent on each other. Okay, so if you check out this node here, like I said, a node has a data and a pointer. Okay, so if you check out this node here, okay, the next node is stored at this address. Okay, and that is what we stored at this pointer, right? So this means that from this node here, we can check out what is in this address, which is the next node. So if you check out this node too, the next node after this node is this node, right? And this node here is stored at this address 320. Now we store that address here so that even from this node, okay, we can check out what is at this address, which is this node. So that's the first thing to note. Okay, now you can see that the nodes are dependent on each other. You have to figure out what is here first before you can figure out what is here, because this is what holds the address of this node. Okay. Now, elements, the second point to note here is that elements are not stored in contiguous memory locations. So if you check out the addresses, they are random. Okay, so this address is at one. This is 100. This is 129. This is 329. This is 500. If you check out the differences between the addresses, it's not constant. Okay, so the elements are not stored in contiguous memory locations. Okay, so let's look at the terminologies that we use when it comes to the linked list data structure. So we have the head. Okay, so the head is the first node in a linked list. So if you check out this diagram, the first node here can be called the head or the head node. So the next terminology here is the tail. So the last node in a linked list is called the tail, and that can be found here. Okay, so the last node is the tail, and take note that the next pointer, okay, in the tail points to null, because after the tail there is no other node, or there are no other nodes. So the next term is a pointer. Now a pointer is a reference to another node. So if you check out this node over here, this pointer stores the address of this node. This node over here is stored at this address 500. Okay, now we store this 500 here so that we can check out what is in the next node right from here. Okay, so the last term here is a node. So a node is an object with two fields, which are a data and a pointer or pointers, because a node can have more than one pointer. Okay, so if you check out this node here, it has two fields, which are a data and a pointer. So that is what makes up a node. All right. So let's look at where the linked list data structure is used. So the first place the linked list data structure is used, according to this slide, is in the implementation of lists, stack, and a queue. So the linked list serve as the base data structure for implementing other lists. So for example, the adjacency list. Okay, you can use it to implement the stack. You can use it to implement the queue. So it serves as the base data structure to implement the data structures. All right, we can also use the linked list data structure to model real-world objects such as trains. Okay, if you look at a train is like different buses that are chained together, right? So you can use a linked list data structure. And also, if you check out this slide, you will discover that we have two arrows pointing back and forth. Okay, so I mean, this can be implemented using a kind of linked list. Okay, also in a place like your music player, you can have previous and next in a music player. Okay, that can also be implemented using the linked list. right? Or image viewer, right? You can check out the previous image and the next image. You can also use a kind of linked list. Okay, so the third use of a linked list, according to this slide, is used for preventing hash collision in a hash table. One way to implement a hash table is the separate chaining. And the purpose of doing that is to prevent hash collision. So in this method, we use the linked list data structure. So the last use of a linked list is to implement an adjacency list for graphs. Okay, so you can implement an adjacency list using a linked list data structure. So types of linked list data structure. There are 4 types. Okay, we have the singly linked list, we have the doubly linked list, we have the circular linked list, and finally we have the doubly circular linked list. So let's check out the first one, which is the singly linked list. So in a singly linked list, each node only has a reference to the next node. If you check out this node here, okay, the only pointer available is just the a pointer to the next node. Okay, it's just one, storing the address of the next node. Okay. The doubly linked list. Now, in a doubly linked list, each node has a reference to the next node and the previous node. In the previous one that we checked, it only has a reference to the next node. But when it comes to the doubly linked list, it has a reference to both the next and the previous node. Alright, so if you check what we have here, the next pointer points to this address, which is where this node. Okay, let me pick up this example. So let's check out this this node here. Okay, so the next node after this node is this node, and it is stored at 320. This address called 320, and that is what we stored in the next pointer. Okay, and also the previous node is stored at 100, right? So we store that here. So you can see that this particular node has a reference both to the next, right, and to the previous node. So that is the doubly linked list. So let's look at the circular linked list data structure. The circular linked list data structure is the same as a singly linked list, except for the fact that the last node points to the head node. So if you check out the tail node here, also called the last node, the next pointer points to the head node. So the head node is stored at 100, right? And that is what we stored in the next pointer here. Okay, and that's why this is called a circular linked list, because you can reference the head node from the tail node. And finally, we have the doubly circular linked list. Okay, so a doubly circular linked list is the same as the doubly linked list, except for the fact that if you check out the head node, okay, the previous pointer in the head node points to the tail node. Okay, and the next pointer in the tail node points to the head node. So that is what makes a linked list doubly circular. Okay, so we can reference the head from the tail, and we can reference the tail from the head. Pros and cons of a singly and a doubly linked list. Okay, so these are the two major kinds of linked lists that we have. So let's compare and contrast. Now, for a singly linked list, okay, it uses less memory. Why? You only need to store the address of the next pointer, of the next node, okay, of the next node. You only store the address of the next node. But when it comes to the doubly linked list, you store the address of both the previous and the next node. So the doubly linked list occupies more memory. Okay, in a 32-bit machine, an address takes up to 4 bytes, and in a 64-bit machine, an address take up to 8 bytes. Okay, so you can see that address takes memory. Okay, so the doubly linked list takes more memory because it stores more addresses. Okay, however, the singly linked list is simpler to implement. Okay, not as the doubly linked list. Also, you cannot easily access the previous elements in a singly linked list. Okay, unlike the doubly linked list where you can traverse in both directions. You can check out both the previous nodes and the next nodes. So that makes the doubly linked list much more usable, okay, but less memory efficient. Okay, thank you very much for this video, for staying to the end of this video. Next, we're going to be looking at the operations performed on a linked list. Please don't forget to subscribe. This is very important so that you can be notified when the next video comes out. Thank you very much. Don't forget to subscribe and see you in the next video. Bye.